I'm with LeakMaster, and this is a short installation video on the UltraFlow V3 leak test instrument. You're going to start by, we're going to see what's in the contents of the box, the shipping box. And this one doesn't have any of the protective padding that we provide with the instrument, but just for ease of videoing, first step is going to be pull out the leak test instrument. Put it on the shelf. And there's an additional box in here. This additional box is going to contain all of your options that you bought, which could be. First thing we're going to do is unpack the contents of the option box. And this is going to contain your manual and any optional equipment that doesn't come standard with the UltraFlow leak tester. So I'm going to open this guy up. Identify all the components that I've ordered. And for instance, this is a DB37 cable for discrete I/O communications. Not always purchased, but if it was purchased, it's going to be in this box. Air prep unit, which is very commonly purchased. Shut off regulator, coalescing filter to provide clean, dry air to the unit. 120 volt power adapter. This will convert 120 volt AC to 24 volts DC. This is what we're going to use to power up the unit in this video. If you are integrating or building a machine and you already have a 24 volt power supply on the equipment that you're building, you likely won't buy the 120 volt AC to 24 volt DC power adapter. So in that case, it's going to come with a Turk cable. This guy is going to be what you would wire up to your power supply. You're going to wire the brown up to your positive 24 volts and the blue to your common. So, also going to receive a manual with it. And we've got cal certificates here. So if you purchased a calibrated leak orifice, it's going to come with an accredited calibration certificate. You would also, on an UltraFlow, you're going to have your pressure calibration report. You're also going to have your flow calibration report for your flow sensor. Now this is all important. It's important to keep all of this information here and pass it on to the end user so they can properly store this in their gauge lab for calibration and recertification purposes. You also see that we provide a swage lock stem fitting, which will plug directly into the front of the tester, and that will be what supplies the air out to the product being tested. A bottle of Snoop for starting up and troubleshooting, looking for leaks on your seal tooling and any fittings that you have in the leak test circuit. A USB stick, which is going to have your an electronic copy of your manual. It's also going to have 3D models, 2D drawings, EDS files, stuff like that. And then you've got the actual hard copy of your manual as well. Okay, now that we've identified all of the components in the packaging, the first thing we're going to do is remove the plastic cover from the leak tester. Now the UltraFlow unit can just sit on an actual shelf, like it's sitting right now, or you could actually firmly mount it down with bolts as well. So if I flip this guy over on its side, you will see that the mounting feet right here have bolts holding them in, but these bolts are also threaded for 832. So if I had a plate here with properly spaced out holes, I can put holes through there, and I could actually go through that plate and lock this guy down with an 832 bolt ×4. For installation purposes, we're going to start with the back of the unit, because this is where all of our interface is going to occur. This is where our air this is where our air supply is going to come in, and then we're going to have a separate supply for our pilot pressure, and then this is where our power is going to come in. Ethernet IP or Profinet is going to be tied to this port. Discrete I/O if you're using discrete I/O for communications to your PLC. And network if you want this connected to the internet for update purposes and troubleshooting. Now that we have the unit unpackaged, the first thing we're going to do is start working on plumbing compressed air into the air supply for the unit. And we always recommend an air prep unit which is going to provide clean, dry air to it. And this is an option that we sell that's going to have a shutoff valve, a regulator, and then a coalescing filter. So this should clean any moisture or oil out of the air line that's coming into it. So with the larger applications like testing exhaust systems, large products, which the UltraFlow is designed for, we want to make sure that we do not choke this down for an air supply, that we don't put any limitations on flow restrictions on the unit before it gets there. So we always recommend coming out of your air source into the air prep unit, out of the air prep unit into a 5 to 10 gallon ballast tank, and then out of the ballast tank into the leak tester. So, and we also recommend a check valve on the input of the ballast tank, so no other equipment can rob air from our station, which can have effects on your leak test results. If another station close by is consuming a lot of air and it pulls air in the negative direction from here, you can see negative flow rates. So it's very imperative to ensure that you have large enough air supply lines, check valve on the input of a ballast tank, properly sized ballast tank, and good clean dry air. Now the first thing we're going to want to do is plumb up our air prep unit. So this guy's going to come with 3/4 inch NPT ports in and out, and I've already got one here with some fittings already threaded into it. So I'm going to come out of my shop supply, which is line pressure at 100 psi. I'm going to come out of line pressure and I'm going to come into my air prep unit. Now that we've got the input supply into the air prep unit plumbed in, now we are going to come to the output side of the air prep unit, which will feed our ballast tank. So note that I've got 1/2 inch hose coming into the air prep unit and out of the air prep unit, and this is going to be high pressure. More than likely we're going to set this guy to 60 psi. We want to be well below our line pressure to ensure that we don't have any pressure drops or fluctuation going into our tank. We're going to come out of our air prep unit into our tank. We've got a check valve right here. Now this will allow us to put air inside the tank, but we can't remove any air from the tank. And that prevents the other stations around us from robbing air from our system and affecting results on our leak test. Now we're going to come out of the ballast tank and we're going to come into the back of the leak tester. I recommend using some sort of fitting that allows you to quickly connect to this. So if you ever had to take this station offline and put a spare in its place, you don't want anything hard plumbed in here to where you're having to cut hoses. So this is just a flare type fitting. I've already got this mounted on the end of the 3/4 inch line here, and I'm just going to connect to it like this. Now I can easily quickly disconnect from this unit. So I've got 1/2 inch line coming from our shop supply going into the air prep unit. You can go bigger with this. Do not go any smaller than 1/2 inch. Actually, the preferred size would be 3/4 inch. We're coming into our ballast tank, but we've stepped the pressure down to approximately 60 psi. Now we definitely want to be 3/4 inch from the tank to the back of the instrument. So when you're inserting fittings into the actual leak test instrument itself, we want this is 3/4 inch NPT input into the air in port here. What we recommend using is the Loctite 567 pipe dope. And this is highly recommended. Do not use Teflon tape on this application, because what happens is the Teflon tape will get in there and there's really no way for it to get out. We have a filter on the output side of the leak tester, the side that actually delivers air to the product being tested. So if you get shavings of Teflon tape in there, they really have no way to get out ever. So we always use this Loctite 567 thread sealant. You're going to thread this fitting in. Tighten it up good and tight so it doesn't leak. And now we're going to take our hose that already has the matching flare fitting. Snug it up. So now we've got air plumbed into the unit. Next step is going to be supplying pilot pressure to the instrument. So the pilot pressure port is 1/8 inch MPT. So you're going to supply your own fitting here of whatever tube or hose size that you prefer. And for this example, I've got 1/4 inch tubing going into the pilot port. So I'm going to tighten this fitting in real quick. Back here on my supply source. Now keep in mind, I'm filtered. I already have one of these before this, so I've already filtered my air, and you still want to have clean, dry air coming in here. But I'm going to supply my pilot pressure here, and it's important to keep this and this separate. You don't want to come on and tee off right here. You want to tee off probably before your ballast tank. Now, if you teed off right here, then you've got clean, dry air. But the purpose of having them separated is if you have large gross leaks at the front end here, say you had a huge leak, you can cause a pressure drop here, and we don't want a pressure drop to occur here because that can affect the function of our valves. If it drops too low, the internal pilot valves won't shift properly. So we want to make sure that we have 80 psi on this at all times. It's regulated down inside with its own precision regulator, so you don't have to worry about that. Just make sure there's sufficient air pressure to this, and it's separated from the air in source. So now that we have the unit plumbed up, we've got the air source to supply the test manifold, and we've got a pilot pressure source. First thing we're going to do is bring air onto the pilot pressure port. And I would also recommend that this always has air on it. So in the event of an e-stop on your machine, if there's any possible way that you can keep air pressure on this and still have your machine be safe, that is the recommended way to do that. We don't want to be dumping air off of our pilot pressure really at all if we don't have to. We just brought pilot pressure up, so we got pilot pressure supplying our valves, so it's going to actuate our internal pneumatic valves properly. Now we're going to bring air on to our air prep unit, which is going to deliver air to our ballast tank. So if I open up my supply valve, I'm going to, you can hear the air starting to fill my ballast tank through the check valve. And I'm going to run this up to 60 psi. Once I get it set to 60, I'm going to lock that in place so it stays put. So now we've actually filled this ballast tank up through our check valve. I can hear it's slowly filling. Got a manual valve on the output of it, so I still haven't delivered air to the actual leak tester yet. So now we've got pilot pressure on, and we have air delivered to our unit. Now that we've got the unit plumbed up, it's time to apply power to it. So there's two options for this. If you don't have a 24-volt power supply, you would be buying the option, the 120-volt AC adapter. So you're going to going to plug that directly into this 24 volt DC power inlet. This is an M12 Euro style connector. Thread that guy all the way in. Plug the other end to a 120 volt AC source. And your power is applied. Now, if you do have a 24 volt power supply on your machine, then you would not have purchased this, and you would have been delivered an M12 Turk connector. So you would just plug this guy into here. The other end is going to go back in your control panel, and you're going to tie the brown to 24 volts, and you're going to tie the blue to your common. Now that you've got power and air plumbed up to the part, for integration purposes, there's going to be a couple ways to communicate with this, and one of them is going to be Ethernet IP, and this is the port right here for machine network. So if you ordered the Ethernet IP or Profinet option, this is the port that you're going to plug into that connects to your PLC network. If you wanted to communicate via discrete I/O, these are 24 volt inputs and outputs, 16 in and 16 out, and this is the cable option that you would purchase for that. So this is a DB37 cable, and it comes, we've already pre-checked this out to ensure that the color code matches the pins that on pin 1 through 37, and then there's a drawing that comes with it that shows you all of the color codes so you can wire it up accordingly. Now we're ready to power the unit up. Simply do that by pushing the power button on the front of the face. You're going to see that it illuminates blue, and now we're starting the boot up process. This process takes about 30 seconds. When it's completed, the LeakMaster LED up here will be illuminated, and the start-stop buttons will be illuminated as well. Now that we've booted up the unit, the first thing we're going to do is do a self-test on the unit to ensure that the internal manifold is leak-free. So when this unit is shipped to you, it's going to be shipped with a plug in it. So this is essentially just like the Swagelok QC8 fitting, except it's a deadhead. So I'm going to make sure that guy is installed, and we're going to go to our program screen, and we're going to select SelfTest PD, which is a default program on program 31. Now, at this point, you're going to have to log in as the admin. So the default password for admin is admin. And if you look in your manual, you can see how you can change this password to a different password if you prefer. So the first thing we're going to do is come in and we're going to set our test pressure. This is already set by default to 5 psi for this self-test. If I come in to set pressure, I can hit air. It's going to deliver air to this port, and it's going to verify that we have 5 psi there. At this point, I can come out and I can run this test. And all we're doing is just testing the internal manifold here to ensure that this guy is leak-free. So 0 leakage, that's perfect. We know we're good to go. So now we are ready to actually plumb up to our test part and start troubleshooting our fixturing setup. So now that we've done a self-test and verified that our internal manifold is leak-free, we're going to remove the plug from the front. You're going to do that by sliding the sleeve forward and pulling the plug out. Make sure you keep this with the station, because this is good for troubleshooting. Now we're going to take, we are plumbed up with an automotive exhaust component here, and we're already sealed up. We've got some manual seal tooling tied to this, and I'm going to take my air line, I'm going to plug it into the front of the UltraFlow, make sure it's locked in place. And now I'm still on the self-test program here, so what I'm going to do is I'm going to start this test. I'm going to hit start. I'm going to immediately pause it during the fill step. You can see it pause during the fill status. And all I'm doing is applying 5.3 psi to this product. And I'm going to come through and I'm going to check every joint to verify that I'm leak free. Make sure there's no bubbles coming out. I'm going to test every joint. And if you have any leaks anywhere, like this, you're going to want to identify all of these leaks and fix these. And this would be on your seal tools. And for example, right here we've got a seal tool. This is a rubber seal. This guy's sealed up good. Once you've verified that everything is leak free, hit the stop button, which vents the product, and now you're ready to start setting up your actual production leak test.